Hi, I'm Ben Jorgensen with Constellation Network, and I'm here with Doug Maughan from the National Science Foundation, also known as the NSF. Doug, do you want to do a brief introduction?
Sure. Thanks, Ben. I'm really excited to be here. I've been with the federal government for 32 and a half years. Prior to the National Science Foundation, I worked at the National Security Agency, at DARPA, and at the Department of Homeland Security.
Can you give us a little more background on what you did over those 30
Sure. I've been funding research mostly in the areas of cybersecurity for 30 years.
Wow.
And most recently at the Department of Homeland Security, initiated some innovative programs funding startup companies, transitioning and commercializing technologies out of national labs, but really been in innovation spaces for 25 years.
Wow, that's awesome. Before I dive into that, I'd love to hear kind of how does one get into the government, and how does one get excited every day to get involved at cybersecurity? And it seems super fascinating. I just want to know how you get into that line of work.
You know, it's quite interesting. You get a college degree and the government is looking for people in technology. It just so happens that I had opportunities very early on to manage a program funding universities. Got me excited about doing and funding research. Decided I could get more done by funding somebody else than just doing my own research. And from then on, I've managed large portfolios of research at those three agencies.
Wow, how much money would you say like you've funded over the past few years?
Over the course of 25 years, I've managed over $1 billion of R&D.
Wow, that's incredible. Primarily for cybersecurity?
Primarily for cybersecurity.
So if you could go into a little bit about what you saw in cybersecurity over the past like 15 years, for example, and what has been the agenda in investing in cybersecurity, and kind of what have the gaps and holes that have existed?
So I think, you know, it's been an interesting ride over the last 20 years, just watching technology development, more of it being done by industry, less being funded by government. More recently, government's getting involved and doing some, but I think we've constantly forgotten the user in cybersecurity. So I've been responsible for a lot of small businesses using small business innovative research and other programs, and 70, 75 technologies that I can point to that have come out of the research pipeline that I've been involved in. But I think still the problem is the bad guy, right? Yeah. And they're pretty innovative too. And so how do we keep ahead of them? Can we get ahead of them? That's always a challenge. I think there's been more and more activity of government and industry working together in the last 15 or 20 years than there was before that, which I think has to happen. Government doesn't own or operate much infrastructure, so industry has to be at the table.
So when you guys talk about funding, what percentage is the government really funding research that's out there, primarily in the U.S.? Do you have an idea of what that would look like compared to private sector?
Compared to private sector, it used to be 30 or 40 years ago that the government was funding a much larger share. Yeah. I think in the 70s or 80s it was like a 70-30, and now it's a 30-70. So
oh, wow.
Industry has funded a lot more and is funding more today than government. I think it's changed a little bit over the last decade in that government is doing more funding, and government is funding and doing more innovation programs where startups and non-traditional contractors are getting funding as opposed to just the traditional companies.
Now, when you talk about industry, you're talking about private sector, you're talking about, just to kind of clear terms.
Private sector. Industry is private sector, large companies, small companies, startups.
Sure.
All of that counts as industry.
Interesting. So one of the things we were talking about earlier was that what we saw in the 1950s to 1980s, you saw the public sector really drive innovation. The 80s to, you could say, 2010, we saw the private sector really drive innovation. Are you starting to see that, and it kind of goes to with what you were saying on the funding, are you starting to see that shift happen where public sector is actually starting to drive innovation in ways that the private sector hasn't been able to?
I think yes, but I also think the government has been trying to get innovation into their operations, and the government isn't always the best first user of technology. So I think the government is often willing to jump in once somebody else has tested it. So you still have benefit and value of industry doing some leading edge deployment, and then government is more likely to jump in. But I certainly believe that, especially in this world of innovation and startups, the government is realizing and understanding that we need to have that in the government as well.
So before I go off track off of the Department of Homeland Security, talk a little bit more about what you think needs to happen for cybersecurity to kind of address a lot of the data breaches that are going on. So I think when we first talked, we talked about how data breaches are continuing to exist, and even with the amount of funding you've done on those programs, what are some of the gaps that still exist, and how can we combat those data breaches that exist?
So I think the majority of the problems in the cybersecurity world are generated by the user. It's the user that clicks on the link that causes the malware to come into your computer.
Sure.
Many of the computer solutions or cyber solutions have been developed by computer scientists and engineers. And I think more lately, people have started to bring the human into the discussion. I think all of these vulnerabilities need to be thought of in terms of how the user uses technology. And in the end, everybody uses the same infrastructure. It's how do I keep the user from doing something bad?
Do you foresee an evolution of that infrastructure to kind of adapt to the needs of the user, or the lack of accountability on the user?
I think the infrastructure is just going to continue to change based on technologies.
Sure.
10 years ago, 15 years ago, big data didn't exist. Right? And now everybody's talking about big data, and everybody thinks in terms of how much data they have and how valuable their data is.
Yep.
And then you have to think about, okay, what do I do from a technology perspective to make sure that that data isn't compromised?
Sure.
Which forces you to think about who has access to it and how do you protect it.
Wow. And what were like a couple of the high level things that you saw as like threats to massive threats when you were considering different technologies or threat vectors from the Department of Homeland Security?
So very early on, we were seeing DNS attacks, DDoS attacks, routing system attacks. We funded a lot of work in infrastructure there with routing security, DNS security, DDoS defenses. Those are infrastructure technologies, and it moved more into end system vulnerabilities, rootkits, and other types of vulnerabilities there. And of course, once the enemy's inside your system, how do you get them out and how do you detect them? So I think there's, the intrusion detection field has been around for 30 years, and we're still not solving all the problems.
Right.
I think more recently people have been thinking about the user and identity management and making sure I can detect who's accessing my machine, they've got the right credentials, and I can protect the person and the system.
Yeah, it is pretty fascinating. In general, users are starting to go, wait, I'm signing off my terms and services, and what are you doing with my data? Like Facebook's doing what with my data? And so you are starting to get this like consciousness coming to life of the end user around data privacy. So it's really interesting. Maybe we can like segue into talking about the National Science Foundation, where you currently are. And so what are you doing at the National Science Foundation? What's your role in that whole world? And
Sure. So the National Science Foundation is one of the largest government agencies funding non-medical science and engineering and research. So NSF funds all kinds of things, everything from polar Arctic programs to genome activity to cyber infrastructure. I'm there now as an office head for a new structure called the Convergence Accelerator, which is a new organization that's been established in the last 12 months. And we're now funding applied research, taking the results of basic research and moving them forward into prototypes and usable products.
Could you talk a little bit about the process of NSF and how they approach research collaboration? What does it mean to be a convergence accelerator? Like, give a little more insight on like what that looks like.
Sure. So traditionally, the National Science Foundation funds what they call single principal investigator grants, which means that's a professor.
Okay.
NSF is traditionally only thought of in terms of academic research. Mm-hmm. What we're doing in the Convergence Accelerator is team-based projects, so it's not a single principal investigator. It has to be multiple organizations and multiple types of organizations. And then we're funding the consumption of basic research into applied research and then delivery of end results over a 33-month period of time. Phase 1 is 9 months, phase 2 is 24 months. The teams get up to $1 million for the planning phase and then up to $5 million for the execution phase of their project.
And who are some of these individuals? Can you talk like their background, what you guys look for?
So we look for, the requirements are multiple disciplines. So we've got teams that have computer scientists and engineers and psychologists and sociologists and economists. The convergence for NSF means multiple disciplines and sharing of ideas in the research. As we mentioned earlier, a lot of the cybersecurity research had been done by single disciplines. We have to think about multiple disciplines as we think about solving large national scale problems. And by doing the Convergence Accelerator the way we've done it, it requires industry or nonprofits or state or local governments to be part of the research team, not just a bunch of academics working on an academic problem. Has to have real solutions at the end.
That's like really refreshing for even a taxpayer to hear, is that there's real outcomes that come to this. But how are your background really kind of set you up for success for this? Like, you go from cybersecurity, which I think is great that you've said like, hey, it's primarily run by data scientists and you need to incorporate other disciplines. So talk more about how you've kind of like segued into that and how you've kind of created a new path.
So I think, I've funded everything from startup companies to small businesses to large industry. And so I think the Convergence Accelerator gives us a new model for the government to engage industry and academia together, which hasn't been there before. None of the programs I ran at DARPA or at DHS were specifically required to include multiple disciplines and multiple types of organizations. And I think that's one of the positive things about the accelerator is it forces the industry participation, because if the academics run a project, they're not going to be well suited to take the project all the way to product and use. If I have industry involved, industry knows how to do that, and industry is better suited to help the team make it more successful as we go through the process.
And how is the government equipped to handle that specifically? I mean, you're talking multiple egos, multiple personalities, expertise. Well,
our job is to manage the project. Yeah. Our job is not to be necessarily the technical expert. We bring in experts to help us manage those projects. From a technical standpoint, our job is managing the research and making sure they deliver as expected. And the government has a lot of smart technical people. Sure. And what is different here is that we really have industry at the table and an opportunity to have them bring what they can to the solutions.
So would you say that you're bringing emerging technologies to the forefront of the government by way of multidisciplinary channels?
Yeah, it's just that in the end, the NSF results, NSF is all about the public good and national security. We're not about producing products that NSF or necessarily other parts of the government will use. They might, but NSF's role and mission is really about public good and national security.
So you don't really own the research, so to speak.
No, we don't. And in fact, we succeed if the research makes it out into the market and people are using it.
Excellent. Yeah. So, and one of the major topics that you guys are focused on, the NSF, is the future of work. Am I correct?
Yes.
Could you go into a little? I mean, my understanding of the future of work is that, and an interesting fact that nearly like 42% of the U.S. workforce is kind of employed by the gig economy. Or are basically 1099ing themselves as independent employees or ICs. independent contractors.
Right.
Could you kind of shed some light on how the NSF sees future of work and what that various use cases that you guys are working on?
So the project is actually called The Future of Work at the Human Technology Frontier, which I think is interesting to think about.
Sure.
The human and the technology, and where do they interact with the technology? Are they interacting with it in the office? Are they interacting at home? Are they a gig worker? What is their work environment? We're looking at it from the standpoint of what types of technologies and capabilities do we need to be creating to help the next generation of the workforce? So what about the kids that are in middle school and high school? What does that work environment look like for them? Especially as we think about technologies like AI and quantum and other kinds of capabilities. What does that mean for their work environment? Does it change? If so, what technologies do we need to have available for them?
And what are some of those technologies? What are you guys starting to see? I mean, because I know there's been a whole refabrication of education in general. So when you talk about the future of work, you're actually talking about educating people on.
Certainly that's part of it. It's an education piece. So education needs to catch up and keep up.
Yeah.
But even the technologies such as AR and VR, how will that be used in the future in an AI environment, in a manufacturing plant, or in an automation environment? Keep in mind, we want to make sure that they're trained and educated as to how to use the technologies. We don't want them to lose their jobs, but there's going to actually be more jobs created as we think about more technologies that come into the marketplace.
Sure. Could you highlight some projects right now, what we were talking kind of earlier?
Sure. I mean, a couple of ones that I think are really quite interesting. One has to do with autism and the autistic workforce. A lot of them are unemployed or underemployed. So what kind of technologies could we create that would help them get a job and help them keep a job, and you taking advantage of the skills that they might have and keep them trained? I think the other one that I think is quite interesting is if you look at the hospitality industry, as that's a very heavy people-centered environment. But if things change and you have more automation in those kinds of environments, what kind of technologies do you have to share with the workforce to make them better equipped to deal with new technologies? Sure. They're not necessarily, we call them the skilled technical workforce. They're not necessarily college degreed, but they're still capable of doing the job. But if the job changes, now how do you handle that?
And kind of on that note, do you feel like the U.S. is falling behind in terms of how we educate our workforce? Do you feel like we're right at kind of an interesting shift? Like, what does that look like in compared to the global stage?
So I think if you look at the global stage, the future of work, everyone has this problem.
Okay. In
a lot of domains, right? I don't know what the numbers are, but it's millions of open jobs globally, right? Yeah. And there are many of them in technical jobs, but there's still plenty of them that are less technical. And I think the U.S., my view is the education system certainly should be accelerated as well. As we think about accelerating technology development, we have to think about how we're educating our middle schoolers and high schoolers. I mean, we're teaching kids in kindergarten, if they don't know how to use the computer, they're learning how to use the computer, right?
Right.
So, I think we have to think about that from a national scale perspective, is how do we change the education piece? Because, we're a large country and it's hard to move because it's a federal-state interaction, where a lot of other countries that are smaller don't have some of our same problems, and they can move much more quickly than we can. So we're certainly not in the lead, but we're probably in the middle of the pack.
Yeah, it's really interesting. I remember growing up and taking a class in middle school on how to do Alta Vista search. And now you think about, like, search is what some 5-year-old is doing now. Do you feel
is Alta Vista even a search engine?
I don't even know. I'm like scared to look because it's like one of those realizations that you go, am I that old at this point? I'm still not old, am I? How are we getting in at early stages of kind of revamping curriculums to embrace future of work? And I feel like this is one of the main sectors that the public sector can provide assistance, because I don't know how many industries. I mean, I know ed tech is actually becoming a big thing.
It is.
But maybe you can talk more to that.
Actually, industry is clued in on this whole problem, especially in the manufacturing and more of the skilled technical workforce. They do understand that there are issues coming down the pipeline. And so one of the other things we're doing as part of our project is looking at how to help the future employers develop technologies to help their existing employees. Upskilling, reskilling is a very popular topic. I don't want to lose my employees if I'm an employer. So what kind of things do I need to think about to help make sure that my employees can compete in the market and stay with the company and not leave and go take another job?
That's pretty fascinating.
So there's a whole economy there of educating the existing workforce. I think gone are the days where you graduate from high school and you stay in a job for 40 years. Your job is going to change many times, and you have to be, and we talk about it as a continual learner.
Yeah.
Is how do I ensure that my workforce is continually learning and improving, not only to help themselves, but to help the company?
Sure. I mean, you're almost optimizing or future-proofing people's jobs and careers in a way that we've never done.
And jobs are changing in new things like AI and that are going to help us move forward. There's going to be a lot of job change, much more so than your parents or my parents ever had to deal with.
Sure, and the other major initiative that the NSF is showcasing is around big data. So as you talk about AI and new technologies, how kind of connect those dots on how the future of work and using new tools connects with big data, and what does big data mean to you? Sorry, there's a lot of questions.
So for us, the project or the program name is called Harnessing the Data Revolution.
Okay.
So if you think about data, we're talking about a data revolution, more and more data available every day. We look at it in terms of something called an open knowledge network.
Sure.
If you think about some of the existing commercial tools, they're based on knowledge networks. We're looking at it from the standpoint of open, where it's available to all, and open data, government and other open data sources available to future users. And the connection to the future of work is exactly as you explained, that as more and more workers are involved in data science, they have to have access to data, and they want to be able to protect data and be able to do algorithms and other types of technical aspects. So they work together in that way. My new jobs are going to be a lot of data science and a lot of large data sets.
Do you think those data sets today are accounted for? Is the right infrastructure in place? Do we have the right security to manage all the data that's being created?
No, I'm sure we don't. There's plenty of room for improvement. I think, based on my background, one of the things I'm always most concerned about is the security of data, whether it's my own or whether it's anybody else's. And how do I make that available to the right people the right way without losing any protections, right? So I think one of the things we're thinking about and talking about is, in fact, the security aspects of large data science. You can do all the algorithms you want on data, but if the data has been compromised in some way or gets compromised in the sharing, or even the algorithms can be manipulated. Mm-hmm. So there's plenty of science that can be attached to the data science problem.
And for the future of work to flourish, we need to have these right measures in place on big data.
Sure, and certainly for the big data to think about, we have to have these things on there as well, security and other kinds of capabilities. We're looking at some really interesting problems. A couple I'll just mention is, if you think about floods, we have floods all around the country, almost all year long, and that's just a US problem. There's floods in other parts of the world.
Sure.
So the data science problem is, how do I gather data on floods and make it openly available so scientists and land planners and others have access to that data so they can try to predict and defend against future flooding? I think that's a really interesting discussion. One of the other ones is looking at the issue of the energy grid, and same problem. Just like with floods, we've had outages, energy outages, depends on hurricanes, tornadoes, other kinds of things. Same idea. How can I use data that's currently available that primarily is only used by companies. If they open that up, make it available to the research community, you can now have a much broader picture of how to defend against these types of natural disasters.
That's fascinating. Yeah. So that's multidisciplinary as well.
Absolutely.
And multi-industry. Are you working with industry to understand their data strategy as well as the government and how they can work together?
So we haven't gone that far, but we hope to get there.
Sure.
So as part of the strategy of the Convergence Accelerator is that it's multiple disciplines, multiple teams, multiple types of institutions. Mm-hmm. They have to have industry, nonprofits, or other state or local government on their team. The idea is getting companies in the energy sector involved in those teams, getting companies in medicine involved with the teams that are doing medicine. So the Convergence Accelerator is built to provide the opportunity for industry to come to the table and work with the research community to solve some of these problems.
Wow, that's fascinating. So you're basically saying that for data interoperability to exist, you also have to have the human component.
You do, and we want them to come to the table as soon as we can get them interested and aware of what we're doing.
Yeah, that's interesting. What do you think is kind of as you look at the research and you're looking at projects, are you planning like 5 years in advance, 10 years in advance?
So, and the National Science Foundation funds a large percentage of the basic research in the country that is not medical. The National Institutes of Health does all the medical related, but NSF funds a large percentage of the non-medical research and development in the country. So we look to be a consumer of that research. As we look at it right now, we're only planning a couple years out. So we'll put out a solicitation soon for our 2020 cohort. We'll put out a request for ideas to the community for 2021. You and all of your teams can respond. But because this technology is changing so quickly, and we're also trying to make sure that what we do is ready for acceleration, so that means the technology is mature enough that there's, most of the basic research is done. So that way we're not 5 and 10 years out. Mm-hmm. The other parts of NSF are 5 to 10 years out.
Okay.
I'm 2 to 3 years out.
Got it. So when you you kind of harvest all this research, how do you disseminate that across the broader government or even to the taxpayers? How can they use this information and kind of equip themselves with what you guys are doing?
So we're a startup inside the government, so we're working on that. And in essence, it's really about how do we make people aware of it, and that the data's there, the projects are there. We'll be having open opportunities for people to come and listen to the teams. They have to participate in a pitch competition in May, and that'll be open to the public. So we are, we're young, we're new, but that is the end goal, is to make sure that we're getting it out there so people can use it. Because in the end, what I want is the research solutions, even though they're not commercial products, to be used and tested. That will help make them better products.
Excellent. That's amazing answer. I'm going to follow up and say, kind of reflecting over what we've talked about today, and also your career over the past 30 years in the federal government, have you started to weave those kind of touch points of working in cybersecurity, exploring the future of work and redesigning how we will work as a country, how we'll stay competitive, and then how data is playing a huge role into our ability to be successful in so many ways? Have you thought about that vision that you have and connecting those dots and how that plays in the future?
So my vision is what we're doing in the Convergence Accelerator gives us the best opportunity to actually solve some of those problems. No matter what we do, cybersecurity is going to be included in some way, but things like the future of work, things like data science, just the first round of the Convergence Accelerator. We'll have other topics, other areas, in other big ideas, or even ideas that the community has, right? And I think the Convergence Accelerator puts us in a position that we haven't been in from a government standpoint before, where we're actually funding the industry participation with the academics. We can even bring in international partners as well. All of that, I think, towards a very accelerated time frame for delivery of solutions. It's very wrapped up in a nice little package that the government's not done before. I think the challenge for me right now is getting industry to the table. They're having them be interested in working with the government and academia and helping them understand that this is an opportunity for them to come and work with some really hard problems and try to bring some solutions that will have big impact.
I think it's an amazing vision. It's really broad, and it's really fun to see that people can collaborate. It's also amazing to hear just how the government is taking a more innovative approach. They're being more agile than what you've seen before, and it's through this vehicle.
Yeah, and I think it's not just what we're doing at NSF. There's more activity across the government in the innovation space.
Sure.
As we talked about earlier, the government is slowly realizing that we need to bring in some of the cutting edge startups and others who are out on the leading edge to bring us solutions faster.
Excellent. You know, I know our community specifically has, Constellation is a blockchain, and we're building blockchain. Has that started to make its entrance into the vision of the NSF, the research? Talk
so
briefly
certainly in the case of what we did at the Department of Homeland Security, we funded blockchain and identity technologies for Homeland Security applications. In the basic research part of NSF, they have funded research associated with blockchain. It hasn't made it specifically to the accelerator from that applied research perspective. I wouldn't be surprised to see it there in the next year or two as we think about other solutions, privacy and other types of technologies that we need for not just for the common user, but for infrastructure and data. But certainly the blockchain idea brings some really interesting data management, data science aspects, as well as security to the table.
Great. And so you think maybe even Constellation could be in that fit?
You can come and play with the National Science Foundation just like everybody else. We want you at the table. The sooner the better.
I love it. I love it. Well, Doug, I would love any last things that you would like to say. How can our community get involved? How can people get involved? What should they do?
So I think a couple things. We'll keep you informed of our solicitation for the next round, which will come out within 6 weeks. When we put out the request for ideas, your community can respond with their ideas as to what they think we should do. They can also submit workshop proposals, and we'll fund community workshops to help develop ideas. So I think there's all kinds of opportunities for your community to come and play. And once we make awards to our phase 2, industry can come to the table and work with them as well, and we'll certainly keep you informed about that as we go forward.
That's amazing. I think it's an awesome opportunity, and I know our community gets behind a lot of things. They'll start knocking on your door, and you'll be like, who are all these people? But
look forward to it.
Yeah, very exciting. Well, Doug, I can't thank you enough for the time today. Really glad to have you in San Francisco. You're normally in the East Coast, so this was a real treat that you came knocking on our door, and we're like, hey, let's do this. So I can't thank you enough.
Thank you so much, Ben.
Thanks, Doug.